So now let's try a proof where we have some overlapping triangles. Anytime we start our proofs, we look at the given information, we mark our congruencies in our figure, and then we figure out how to logically go through the proof. So first thing we're given is that AC is congruent to AB. So AC, now this is a little bit tricky, AC is this side right here, is congruent to AB, which is this longer side. So those two sides are congruent. We also know that AE is congruent to AD. So AE is this segment right there, and AD is this segment right here. So this could start to get a little bit confusing. You want to keep in mind that we probably have overlapping triangles. It's kind of clear in the picture, and it might be nice to separate those out and see, maybe draw them separately to see what these might look like. So for example, let's say that one of your triangles was this one right here. Oops, here we go, ACE. So if I were to draw that off on the side, it would look like this. Oops. There's A, there's C, there's E. Now another triangle that is overlapping it is this one right here. Make that a little, there we go. A, D to B. Alright, so if I draw that one separately, it's going to look something like this. And I know these aren't perfect drawings, but hopefully we get the idea. A, D, B. Alright, so it's kind of like we took the two triangles and just pulled them apart from each other and redrew them. So from here, now let's look at our given information again. AC is congruent to AB. Well, here's AC right there, congruent to AB. So we've got that side that's congruent. We also know that AE is congruent to AD. Alright, so let's start looking at the proof. We're going to have another congruency to mark in, but we'll take care of that when we get to that step. So in our statements, AC is congruent to AD, and AE is congruent to AD. That's AB up there. How do we know? This is given. I'm just going to write it once, like that. So that's our given information. Now, when you're trying to prove that other parts of the triangle are congruent, you want to prove that the entire triangles are congruent, and then you can use your CP/CTC to say that these individual pieces are congruent down here. So, what else might be congruent? Take a look at your two triangles, either separately here, or it might be a little bit more clear up here. Do they share anything? And take a look at your angle A, and it looks like they do share angle A. So that means in our picture over here, when we separate it, the angle A is congruent to angle A. So there's our other congruency that we need. And how do we know that it's congruent to each other? That's your reflexive property. Don't you guys love that now? Reflexive property is so nice. Alright. So now that you have a few congruencies, do we have enough to say that the triangles are congruent? So you've got a side congruent to a side, an angle, and then another pair of sides. And this angle is included between the two. So there is your side, angle, side congruency. So yes, we can say that our two triangles are congruent. We can say triangle ACE is congruent to triangle ABD. And that's from your side, angle, side congruency. And then what you're trying to prove is your last step. And now that you have congruent triangles, then every corresponding part will be congruent. So this is going to be, we know that CE is congruent to BD because of our CPCTC. Corresponding parts of congruent triangles are congruent.